This video lesson is over freefall, which includes objects that are falling. So here I have a baseball that is falling probably to the ground, but just falling nonetheless. Freefall also includes objects that are going up. So a baseball or an air rocket, something like that. Or could be going up and then back down. So what does freefall even mean if it's also objects going up? So free fall is what we call a situation where an object is under the influence of a single force, which is gravity, is said to be in free fall. So in all these three situations, the only force acting on the ball is a downward force of gravity, which for today we'll call Fg. Okay, in all of these situations, gravity is acting. Gravity is the only force acting on the ball. So all objects in free fall near the surface of the Earth experiences a constant acceleration. We call it the acceleration due to gravity, which in real life is 9.81, really close to 9.81 meters per second squared downward. But for the AP test and this course, and for quizzes and for tests, we're going to use 10 meters per second squared downward. Okay, and of course, this is all assuming that we neglect air resistance. We're not going to consider the air resistance, which would be a force acting on the object, because if that is acting on the object, then we can't say it's in free fall. And where does free fall work? Pretty much anywhere on the surface of the Earth, which this doesn't look like much, but could be any of the lowest point you've ever been to the highest point you could ever go, um, is close enough to the surface of the Earth that this works. So let's continue. Okay, real quick before we get to an example, our sign convention. If an object is going upward, so it has an upward velocity, we are going to call that direction, that y direction, positive. In other words, we would put a positive in front of that number. So this was 3 meters per second up, we would say positive 3 meters per second. If an object has a downward velocity, we would assign that a negative. Put a negative on that number. So 3 meters per second downward would be negative 3 for our equations. And so for that matter, since we're using acceleration is 10 meters per second squared downward, we will put a negative on that acceleration. So when we get to that, because acceleration due to gravity is downward. Cool. So let's do an example. A ball is dropped from a height of 2 meters. How much time to hit the ground and what velocity does it hit the ground with? So we'll break all this down. We're going to be using our kinematics equations, but we need to modify something. So x naught is the position at time 0, and x is the position of the object later in time, which still holds, but why don't we call this the height, since now we're looking vertically. Height at time 0, which is in meters, and this would be the height. Sorry, let's move this down. This would be the height later in time. Which is in meters. So when we solve these, we're going to make our lists. Our list. So again, initial height, or the height at time 0, some later height. So the ball is dropped from a height of 2 meters. That is the height at time 0. We can imagine that it's, you know, falling. This is later and later and later in time. It says, how much time does it take to hit the ground? So the height at time t would be 0 because the ground is 0 height. This is free fall, so our acceleration is negative 10 meters per second squared. Negative because of our sign convention. And there's one more thing we know, and it's this word dropped. So I want you to think about this. We could be throwing the ball upward, but we're not. If we throw the ball upward, well, let's not do it like that. We would be giving it some positive number for the velocity. If we were throwing it downward, we would be giving it some negative number for the velocity. But if we're dropping it, we are doing neither of these. And so when you drop something, we are giving it zero height. So this is important to note. Zero height, zero velocity, sorry. When we are dropping something, we are giving the object 0. The initial velocity is 0. Cool. How much time does it take to hit the ground? Well, we need an equation with t, but it needs to be missing v because we don't have it. So that takes out equation number 1. It's got to be equation number 2. So let's substitute some numbers. X naught is 0. X is 2. V naught is 0. So 0 times t is 0. So this whole thing is 0. So I'm not going to write it. Now we have 1/2 a is negative 10 t squared. Negative 10 times half is negative 5. You know what, let's do it this way. We'll try to isolate t. I'll get rid of this negative as well, so we'll add 5t squared to both sides. We get 5t squared equals 2. We'll divide by 5, and then we'll square root it. So 2 over 5, I believe, is 0.4. We will square root. So the square root of 0.4, 0.63 seconds. Cool. You could put this number in the list, but remember, we don't grade it here. We grade it over here. Box it in. Make sure your answer shows it's equal to t. Cool. And then for part B, we're just going to solve for v. That's very simple. We'll just use our first equation. I'll do that here. V naught is 0. Just a times t. And this is why we round it off to 10 instead of 9.8, because we can just do this in our head. 0.63 times negative 10 is negative 6.3 meters per second. Well, actually, I'm going to take this back. This is what you will get out of your calculator, negative 6.3. This is what we will use for calculations, negative 6.3. If we ever needed v, there will be a situation where we do need to use, what we solve for, but it's negative. Make sure you use the negative in your equations. But when we are giving an answer, let's say the velocity is 6.3 meters per second, and we will, instead of writing negative, we will write a direction which is downward, according to our sign convention, which we set up here. Downward is negative, so we'll go the other way. And we want to be getting used to this. Okay. Now, but just to reiterate, if we need to use this number in some other equation, well, we got to make sure that that negative is there because the equation won't understand downward. You can't write that in there. Anyway, that's it.